I'd like to describe a little experiment that I recently did with some flashlight cells, some AA alkaline cells, 4 of them to be exact, a voltmeter, and, not shown here yet, a light bulb. You may have seen a video that I made just a little while ago in the playlist Mysteries and Musings, and I'm putting this one right after it in that playlist because there's something that I neglected to do in that previous experiment. Now, in that experiment, I had a 6-volt lantern battery connected in series with 2 AA flashlight cells, and then I reversed one of the cells to see what would happen, and then I reversed both of the cells to see what would happen. By reversed, I mean I reversed their polarities. Each one of these individual cells, all by itself, provides about 1.5 volts. Now, there's a slight variation from cell to cell as I've measured them. In fact, they provide about 1.6 volts until you put a significant load on them, and then the voltage drops to about 1.5 volts. But generally speaking, let's round off these numbers to get rid of the experimental error, which never exceeded the limit of acceptability. So all of the results here are approximate, but what I actually measured is within the realm of experimental acceptability. The errors were very, very small. Just the kind of thing that you expect in a physical object. They're not perfect. Each one of them has 1.5 volts, so you'd expect the entire combination, if you connect them in series, minus to plus like this, as shown here, you'd expect the entire combination to produce 6.0 volts, and that's exactly what happens. In fact, this same 6.0 volts will be observed even if we place a load on the batteries. Just a slight drop. Actually, I measured 6.4 volts without a load and 6.0 volts with a load, but what I was interested in seeing was what would happen if I reversed the polarity of one of these cells with and without a load. In the previous experiment, I did that and the results were not particularly surprising. If I reversed one of the cells in the previous experiment, just reverse the polarity like that, instead of 6 volts, I now got 3 volts. Or this is what I got when I did this experiment here, which is a little different because instead of a lantern battery and 2 cells, I just used 4 cells. If I reversed the first one, then I would get minus 1.5 plus 1.5, that's 0, plus 1.5, that's 1.5, plus another 1.5, that's 3 volts. So if we actually go and do the arithmetic, what we ordinarily will see if we connect these 4 things in series properly is that the voltages will add directly, and we'll get 6.0 volts. And that's exactly what we do find. If we reverse the first cell, minus 1.5 plus 1.5 plus 1.5 plus 1.5, now these two cancel each other out, and we are left with 3 volts, 3.0 volts. So that's not terribly surprising. That's what theory predicts, that's what arithmetic predicts, and that's exactly what I did find. But I became curious. I wanted to see what would happen if instead of just reversing the first cell, I reversed the second cell instead. What would happen then? Well, theory would predict something very similar to the previous situation, but not quite the same. 1.5 minus 1.5. Well, isn't that cute? Plus 1.5 plus 1.5 equals, okay, they cancel out again. We've just reversed the order of the sum in the arithmetic. Well, in pure arithmetic, we still get 3.0 volts, and in fact, in the experiment, that is exactly what I did find. The same result. It didn't matter whether I switched just the first one or just the second one. And in fact, by doing that, I was able to account for all possibilities with 4 cells. Try it and see. If I was to reverse 2 of these, then I would expect 0 volts, and that's exactly what I got. So, my question then became, okay, we did all of this without any load connected. I wonder if the same thing would happen if I put a standard 6-volt lantern bulb here. So I went ahead and I measured the voltage with the cells all connected up the way they're supposed to be, and I got the 6 volts that I would have expected to get. Actually, I got about 6.0 volts in this case, as opposed to a little bit more without the load. The load causes the voltages of the batteries to, or the cells here rather, to drop slightly. The more robust the cells, the less the drop. And that's important to know. AA cells, when I connected this bulb up like this, I actually measured the current at this point right here by inserting an ammeter in there. And when I did that, I got a current of 0.24 amperes. 0.24 amps. That's just about a quarter of an amp. That means that 6 volts times a quarter of an amp, that's a 1.5 watt bulb. That's drawing quite a bit from these 4 little AA cells. Well, now I reversed one of them or the other, as I did before. And in fact, when I did this, reversed the first one, once again, I got the same exact result that I got in the first case without any load. The same result. Now, I didn't know this, and theory indicates that, I mean, common sense would indicate that that's what should happen, but sometimes electronic and electrical components do not behave the way you think they're going to. You need to do an experiment in order to really see whether it's going to do what theory predicts. Even if you think that it has to, it's always good to do an experiment to check it and see. So I reversed the second one. I wanted to see whether it was going to do the same behavior as it did without the load, and in fact, yes, it did. So none of this was particularly surprising. There is, if you want to do experiments like this, I would recommend something very, very strongly. In fact, I would demand it. Do it with alkaline cells only. Alkaline cells only. You can find these just about at any store you go to in the United States, alkaline cells. Do not try it with lithium cells. If you find lithium cells, do not try this experiment with them, because when you put these cells under load, you are demanding current from them, and the current through the rogue cell, the reversed cell here, in this case it would be the second cell, it's going to be driving a backward current through there, and that's a lot like a short circuit. And you may have heard what can happen to a lithium cell if you short it out. It can blow up. So do not, under any circumstances, try this with lithium cells. All of this and other interesting stuff you can find in my book, Electricity Experiments You Can Do at Home. Just go to my website, sciencewriter.net, and you'll find a link to my Amazon repertoire of books for sale there, and you can find it on that site. There's a lot of stuff in that book that really surprised me. Experiments like this I did in that book, and I was not particularly surprised. But I did do some experiments of a little more esoteric nature in there, and I was very surprised in some cases when I found out what happened. That's always fun, you know, when a theory that you have gets debunked. When you try an experiment and you find out that your theory was wrong, I always think that's a lot more fun, as long as I don't blow anything up. Once again, do not use lithium cells. Do not. Stan Gibilisco signing off until the next little experiment.